Hi everyone. Today we're going to study bar charts and pie charts. Let's begin with bar charts. Bar charts, or sometimes called bar graphs or bar diagrams, are used to represent categorical data. Bar graphs consist of bars that are separated from each other. The bars can be rectangles or they can be rectangular boxes used in three-dimensional plots, and they can be vertical or horizontal. These are steps to construct bar charts. Step 1. Draw a horizontal line and assign it to category, and vertical line for the frequency. Step 2. Represent each item in category by rectangles of equal width and height corresponding to its frequency. These steps will result to vertical bar charts. Interchanging categories and frequencies in step 1 would give a horizontal bar charts. Let's have an example. The following table shows the number of admissions at a training institute for the months January to June. Construct a bar chart for the data. We have a table here with two rows. The first row is for category month, and the months are listed January, February, March, April, May, and June. The second row is the number of admissions, or we can say the frequency. The first is 100 for January, 150 for February, 300 for March, 250 for April, 200 for May, and 150 for the month of June. Here is the bar charts corresponding to the given problem above. Take note that this is our horizontal line, and the category month is listed in here. Also, this is our vertical line here, and the number of admissions or frequency is assigned here. The vertical line is numbered on some intervals from 0, 100, 200, and 300. We stop on the 300 because the highest frequency here is 300 only. Please observe that our rectangles here are of equal width, and they represent each month with the corresponding number of admissions. The first rectangle here represents the month of January, and the height of the rectangle corresponds to the number 100 with respect to the frequency. The second rectangle is for February, and the frequency is 150. So the level here is between 100 and 200. The third rectangle is for the month of March, and this is the highest numbered frequency. The fourth rectangle is for the month of April, and the frequency is 250. You can see here that the level of the rectangle is between 200 and 300. The next rectangle is for the month of May with the frequency 200, and the height of the rectangle is on the level of the 200 frequency. The last rectangle is for the month of June, with the frequency 150. We can see also that the level or the height of the rectangle is in between 100 and 200. So we are done with our bar charts for our example, and this is our final answer. Let's go now to pie charts. Pie charts or pie graphs are also used to represent the categorical data. This representation gives emphasis to the relative weightage of each category. In a pie chart, a circle is drawn, and it is divided into sectors. Number of sectors will be the number of categories. The area of each sector is proportional to the frequency of the categorical variable it represents. These are the steps to construct pie charts. Step 1. Compute for the sum of all frequencies, denoted by n. Step 2. Find the percentage of each frequency, denoted by f, category by the formula percentage equals f over n times 100%. Step 3. Find the angle corresponding to each frequency category by the formula angle equals f over n times 360 degrees. Step 4. Draw the pie chart corresponding to angle and percentage of each item of the category. Let us see one example here. In a university, there are 400 students in the foundation program, 450 in the first year diploma, 350 in the second year diploma, and 250 in the higher diploma. Construct a pie chart for the data. It is advisable that we put the data in a table. I have here a table with 4 columns. The first column is reserved for the level, and the levels are foundation, first year diploma, second year diploma, and higher diploma. The next column is for the frequency. There are 400 students in the foundation program, 450 students in first year diploma, 350 students in second year diploma, and 250 students in higher diploma. There are 2 additional columns, namely percentage and angle, that we're going to fill in the blanks for these 2 columns. Let's go now to step 1, and that is to compute for the sum of all frequencies. Taking the summation of this column, we will have n equals 1450. Step 2. Find the percentage of each frequency category by the formula percentage equals f over n times 100%. Let's start with our first blank here. So we're going to use the 400, and that is the frequency of the first level, divided by the 1450, and then multiply to 100%. and the answer is 27.6%. We will copy this value on this blank, and here we go. For the second blank, 31%. We got this when we have this 450 divided by 1450 times 100%. The next blank is 24.1%, and that is when we have the 350 divided by 1450 times 100%. The last blank is 17.2%, and this comes from 250 divided by 1450 times 100%. After that, let us get the total of this column. We will have 99.9%, and this is equivalent to 100%. Now, let us go to step 3. Find the angle corresponding to each frequency category by the formula angle equals F over N times 360 degrees. Let's begin with the first blank here. It means, again, I'm going to use the frequency value and then divide by the N, 1450, times 360 degrees. This is equal to 99.31 degrees. This value we will copy on this blank. So we have now this 99.31 degrees. Next, for this blank, we will follow the same formula. So we will get 111.72 degrees. We will get this when we have 450 divided by the N, 1450 times 360 degrees. So the value is here. The next is 86.90 degrees. This value comes from the 350 divided by 1450 times 360 degrees. And the last blank is equal to 62.07 degrees. This comes from 250 divided by 1450 times 360 degrees. And the value is written here. Now let us take the summation of this column, and we will have the answer 360 degrees. This must be always equal to 360 degrees. On the same way that this column must have the summation that is equal to 100%. Now, let us go to step 4. Draw the pie chart corresponding to angle and percentage of each item of the category. So let us minimize our table because we are going to draw the pie chart. This is the finished product or the pie chart of this example. Please observe that in the pie chart, we are putting the percentage for each item of the category. Let's start with the first one, the foundation. So this 27.6% is written here. And for the angle, 99.31 degrees, it is estimated in the central angle. The next level is for first year diploma, which is 31%. And here is the 31% in red-orange color. And the central angle here is estimated to be 111.72 degrees. The third item is second year diploma with 24.1%. Here we go. And the angle is 86.90 degrees. And this is the angle. The last level is the higher diploma with 17.2%, and there we write the 17.2%, and the central angle is estimated to be 62.07 degrees. We can see here that our pie chart is colorful. However, in our daily class activity, what we can do is simply put each level opposite its corresponding sector. It means to say, the foundation program, we can write somewhere here. The first year diploma, we can write somewhere this side. The second year diploma may stay here. And the higher diploma, we can write somewhere here. And this is our final answer. I hope you learned something from this video. See you again next time. Today we're going to study histogram. A histogram consists of contiguous or adjoining boxes. It has both a horizontal axis and a vertical axis. The horizontal axis is labeled with what the data represents. The vertical axis is labeled either frequency or relative frequency or percent frequency or probability. The histogram can give you the shape of the data, the center, and the spread of the grouped frequency distribution. Example 1. Draw the histogram for mathematics marks of 60 students. This is our table. Let us draw the vertical and horizontal axis. The vertical axis is for the frequency. We write the numbers and we made sure that the highest frequency is defined in our numbering. For horizontal axis, this is about the marks. We will consider the class intervals. Now, we will define the class limits from 0, 10, 20, up to 60. Now, let us start drawing the histogram, starting with the first class interval. Let us write the box for this first interval. From 0 to 10, the frequency is 2. This is the box. Second class interval. From 10 to 20, the frequency is 10. This is our box. Third class, from 20 to 30, the frequency is 21. Here it is. Next class, from 30 to 40, frequency is 19. Here we go. Next class, from 40 to 50, frequency is 7. This is our box. Last class, from 50 to 60, 1 frequency. This is our corresponding box. Now, our histogram is complete. Example 2. Given the histogram, answer the questions. There are 2 questions here. But before we answer, let us analyze the histogram here. This is about the ages of 25 teachers of a school. In our vertical line, this is the frequency of teachers. For our horizontal line, these are the ages in years of the teachers, and we put the class limits. Note that it started with 20, then 25, 30, 35, up to 50. That means the ages of the teachers are from 20 up to 49. Also, there are no teachers below 20 years old. Now let's answer the first question. How many teachers are of age 45 years or more, but less than 50 years? This question corresponds to the last box, from 45 to 50, and the frequency is 5. So the answer here is 5. Second question. How many teachers are of age less than 35 years? In our horizontal line, the number 35 is here. There are 3 boxes less than 35 years. So we add all the frequencies, 6 plus 5 plus 4, and the total is 15. There are 15 teachers who are less than 35 years old. There are frequency distributions with common value of class limits, just like this, and we are able to draw the histogram for this. However, there are frequency distributions with no common class limits. This is our example of frequency distributions whose class limits are not common. In this case, we're going to draw or construct histogram for this type of frequency distribution. Here are the steps to construct histogram. Step 1. Compute for lower and upper class boundaries of each class interval. The formula is given. For upper class boundary, that is equal to UL sub C. This UL means upper limit of the class interval, plus LL sub N. This is lower limit of the next class interval, all over 2. The upper class boundary of a particular class is equal to the lower class boundary of the next class. Step 2. Draw horizontal line and number it for class boundaries accordingly, and vertical line for frequencies. Step 3. Describe the classes by rectangles using lower and upper boundaries as widths and frequencies as height, respectively. Let us see one example. For 108 randomly selected college applicants, the following frequency distribution for entrance exam scores was obtained. Construct a histogram for the data. We have a table here with 2 columns. The first column is for class limits or class intervals. We have 1, 2, 3, 4, 5 groups. The first class interval is from 90 to 98. The second class interval is from 99 to 107. The third is from 108 to 116. The fourth class interval from 117 to 125. The last class interval is from 126 to 134. The second column is for frequency. There are 6 observations for the first class interval: 22, 43, 28, and 9 for the other class intervals respectively. We need 2 more columns, and these are lower class boundary and upper class boundary respectively. Let us now solve for this first blank here for the upper class boundary, which is for the first class interval. The formula is given to us, which is upper limit of the class plus the lower limit of the next class divided by 2. It means to say the upper limit is 98 plus the lower limit of the next class, which is 99. So we see here 98 plus 99 divided by 2, we have 197 over 2, that is equal to 98.5. We will copy this value on this blank, and there we go. Next, it was stated that the upper class boundary of a particular class is equal to the lower class boundary of the next class. So we have 98.5 for this blank, which is the lower class boundary of the next class. Going to our upper class boundary of the second class interval, we will use the same formula. So we have 107, the upper limit, plus 108, the lower limit of the next class, divided by 2. This is equal to 215 over 2 equals 107.5. And this value we will write here. Again, this 107.5 we will copy down here as the lower class boundary for the next class. Then, let us compute for this upper class boundary of the third class interval. So we have 116 plus 117 all over 2. This is equal to 233 over 2, which is equal now to 116.5. And this value we will copy here. And this 116.5 will be same as the lower class boundary of the next class. Then, let us compute for the upper class boundary of the fourth class. We have 125 plus 126 divided by 2. And that is equal to 251 over 2. And the quotient is 125.5. This value we will copy in here. Also, this 125.5 is the lower class boundary of the next class. And there we go. Then let us compute for the upper class boundary of the last class. We may use our same formula here. But did you notice a pattern here? Looking at the upper class boundary, it seems that the upper class boundary is equal to upper limit plus 0.5. Look at this 98.5. We can see that the upper limit is 98 and this is 98.5. It's like the 98 plus 0.5 will give the upper class boundary, which is 98.5. The same is for 107.5, that is 107 plus 0.5, we will get this value. And that is also true for this 116.5 and also for 125.5. It means to say Using that pattern, we can simply get the value for our last blank, the upper class boundary of the last class, and that is 134. This upper limit plus 0.5, we will get 134.5 that we can write in here. Also, for the lower class boundary column, if we look at our lower limit, this is 99. It seems that this 98.5 is the result when we have lower limit minus 0.5. So you see, this is 99 minus 0.5 will give 98.5. Also, this 107.5 may come from 108 minus 0.5. This 116.5 comes when we have 117 minus 0.5. And the last, the 125.5, may come from 126 minus 0.5. On the same note, we can compute for this blank, for the value lower class boundary of the first class. We can get the lower limit 90 and then minus 0.5, and we will get this 89.5. We may copy now this value for our lower class boundary of the first class interval. Our table now is complete. Let us now write the histogram. First, let us draw the horizontal line and the vertical line here. In the horizontal line, we will write the class boundaries, and for the vertical line, we will write the frequency. Now, let us describe the first class interval. Take note, the first class interval has lower class boundary of 89.5 and the upper class boundary is 98.5. So this is from this point up to this point in our horizontal line. So the rectangle corresponding to our first class interval is given here. The width is from 89.5 to 98.5 and the height is up to the level of 6 in the frequency. For the second class interval, we have the class boundaries from 98.5 to 107.5. So this is our interval, and the rectangle corresponding to that is this one with a height that is equal to 22 in the frequency. The third class interval has class boundaries from 107.5 to 116.5. And the rectangle for this class is given here with a height of 43 in the frequency. For the fourth class interval, we have class boundaries from 116.5 to 125.5. And the rectangle corresponding to this is given with a height that is equal to 28 in the frequency. For our last class interval, whose class boundaries are 125.5 and 134.5, the rectangle is given here with a height that is equal to 9 in our frequency. So this is our histogram now, and this is our final answer. I hope you learned something from this video. See you again next time. Today we're going to study rectangular coordinate system. In particular, we're going to study plotting of points and the quadrants. Let us define rectangular coordinate system, or sometimes called Cartesian coordinate system. The rectangular coordinate system consists of two real number lines that intersect at a right angle. This horizontal line is called the x-axis and the vertical line is called the y-axis. These two number lines define a flat surface called a plane. The intersection of these two lines is called the origin. If we look at our x-axis from the origin going to the right side, we will number this portion as positive numbers, starting from 1, 2, 3, 4, 5, so on and so forth. Also, from the origin, going to the left side of the x-axis, all numbers here are negative, starting from -1, -2, -3, -4, -5, so on and so forth. Looking now at our y-axis, from the origin going upward, all numbers are positive. So you see, this is +1, 2, 3, 4, 5, so on and so forth. From the origin going downward of the y-axis, all numbers are negative. -1, -2, -3, -4, -5, so on and so forth. The rectangular coordinate system is composed of so many points, and each point on this plane is associated with an ordered pair of real numbers xy. An ordered pair xy represents the position of a point relative to the origin. The first number here is called x-coordinate or abscissa, while the second number is called y-coordinate or ordinate. Let us learn how to plot a point on the rectangular coordinate system. Let's begin with an example. Plot the point +2 and +3. Always remember, the first number represents the x-coordinate. The second number is for the y-coordinate. Looking now at our rectangular coordinate system, let's start with the number 2, that is for the x-coordinate. We will look at our x-axis. The +2 is here. Then we will look now for the y-coordinate, and that is +3. From the origin, we go up, that is the +3 of the y-axis. And then we will get the intersection of this +2 of the x and the +3 of the y. So here is the point. Let us have more examples. Plot the points. We have here 5 points. Let's begin with the first point, 4, 0. The 4, 0 is here. This is the point. So the first number is 4, that is for the x, so that is positive. From the origin, we go 4 units to the right. Then the y-coordinate is 0, so this is now the point 4, 0. The next number is -6, 0. So let's begin with the -6. It means that is for the x-coordinate. We look at our x-axis. From the origin, we go 6 units to the left. So this is the negative 6. And our y coordinate is 0. So this is the point, the negative 6, 0. The next is the point 0, 3. We begin with the number 0, that is for the x coordinate. Our x-axis is here, the value 0 is here, and then the y coordinate is 3. We go 3 units up. So this is now the point 0, 3. The next point is negative 2, 6. Let's start with the negative 2. It means from the origin, we go 2 units to the left. This is the negative 2. And then the y coordinate is positive 6. From the origin, we go 6 units upward. And then we will take the intersection of the negative 2 from the x and the positive 6 from the y. And here is the point. The last ordered pair here is negative 4, negative 6. Let's begin with the x coordinate. Negative 4 means on the x-axis, from the origin, we go 4 units to the left. Here is the negative 4. And then for the y coordinate, it is negative 6. From the origin, we go downward 6 units. So this is now the negative 6. Then we take the intersection of the negative 4 and the negative 6 here, and here is the point. Hi everyone. Today we're going to study line graph. A line graph displays data that changes continuously over periods of time. For example, in a hospital, a doctor maintained a record of a patient's body temperature taken every 4 hours. This time temperature graph is an example of a line graph. At first, data is collected in tabular form, just like this. And then, this is converted into line graph. In this graph, the horizontal line or the x-axis shows the timings, while vertical line or y-axis shows the temperatures. Each data is plotted and adjacent points with respect to the timing are connected by line segments. For these 4 pairs of data, here are the points. Then we connect them just like this. Then we have a line graph. Another example, the given graph describes the distances of a car from a city, capital P, at different times when it is traveling from city P to city Q, which are 350 kilometers apart. Study the graph and answer the following. First question, what information is given on the 2 axes? In the graph, it shows that the horizontal or x-axis shows the time, and the vertical or y-axis shows the distance of the car from city P. Second question, from where and when did the car begin its journey? Looking at the graph, we can say that the car started from city P at 8 a.m. Third question, how far did the car go in the first hour? In the graph, it shows that The car traveled 50 kilometers during the first hour. That is starting from 8 a.m. up to 9 a.m. as seen from the graph. Fourth question, how far did the car go during the second hour, the third hour? Observing the graph, the distance covered by the car during the second hour, that is from 9 a.m. to 10 a.m., is 100 kilometers. Looking at the graph, at 9 a.m., the car is at 50 kilometers. At 10 a.m., the car is at 150 kilometers. So, 150 minus 50 is 100 kilometers. What about on the third hour? That is from 10 a.m. to 11 a.m. The distance covered by the car will be 50 kilometers. In the graph, it shows that at 10 a.m., the car is at 150 kilometers, while at 11 a.m., the car is at 200 kilometers. So that will be 200 minus 150. We will get this 50 kilometers. Fifth question, did the car stop from some duration at any place? Justify your answer. In the graph, it shows that the car was 200 kilometers away from CTP when the time was 11 a.m. up to 12 noon. Thus, the car did not travel by this time. As we can see in the graph, there is a horizontal line segment from 11 a.m. up to 12 noon. Sixth question, when did the car reach city Q? On the graph, it shows that the car reached city Q at 2 p.m. Today we're going to study graphs of linear functions. First, let us define linear functions. A linear function is a function whose graph is a line. Linear functions can be written in the slope-intercept form of a line. This is f of x equals mx plus b. We know that m, the coefficient of x, is the slope of the line, and the b is the y-intercept. Showing the ordered pair, we can write 0, b. As defined, y-intercept is the point where the graph intersects the y-axis. Also, there is x-intercept, and that is the point where the graph intersects the x-axis. To illustrate, we have here a line, and with respect to the rectangular coordinate system, this point here is the y-intercept, while this point is the x-intercept. To find the x-intercept, we set a function equal to 0 and solve for the value of x. So, given f of x equals 0, we can have mx plus b equals 0, and this positive b is transposed on the right. The sign is changed, so we have mx equals negative b. Since we want to get x alone, On the left side, we will divide this equation by m. So the m here will be cancelled out, only x comes down, and this is equal to the negative b over m. So the x-intercept equals negative b over m. We may use this formula to get the x-intercept. To summarize, the general form of the linear functions is f of x equals mx plus b. The y-intercept, we may write the ordered pair 0 and b. For x-intercept, it has the ordered pair with x coordinate negative b over m. Take note, this b is that y-intercept over the m, which is the slope of the line. Then comma 0. How to graph a linear function? We are going to follow two steps. Step 1, find the intercepts. Step 2, draw the line connecting the intercepts. Let's have examples. Find the slope and intercepts and then sketch the graph of the linear functions given below. Number 1, f of x equals 3x minus 6. So we write the general form of the linear functions here. The f of x equals mx plus b. First, we can collect the slope, which is the coefficient of x, and that is 3. Followed by the y-intercept, which is the negative 6. And if we write this in the ordered pair, it will be 0, negative 6. For the x-intercept, we're going to use this formula, negative b over m. Substituting the values, this is equal to, first, the b is negative 6 over the m is 3. And then this negative and negative becomes positive, and 6 divided by 3 is equal to 2. To show this as an ordered pair, we will write 2, 0. Now, let us sketch the graph. Let us show the x and y axis, and then identify the negative 6 in the y-axis and the positive 2 in the x-axis. Then let us plot the points. First is 0, negative 6, that is the point, followed by the 2, 0, that is the point. And then we will connect the 2 points, and this is now the line f of x equals 3x minus 6. This is our final answer. Let us have example 2. Let us find the slope and intercepts and sketch the graph of this f of x equals 4 minus 2x. The general form of linear functions is written here. For our convenience, we may rewrite this problem in such a way that the negative 2x comes first. And from here, we will collect now first the slope, and that is the coefficient of the x, which is negative 2. Next is the y-intercept with coordinates 0, 4. You can see I copy directly the constant in the function, and it is written here. Next is the x-intercept. We will follow the formula negative b over m. and substituting the values, this is equal to negative 4, that is the b, over the negative 2, which is the slope. And then we simplify, negative and negative becomes positive. 4 divided by 2 is equal to 2. Showing now the ordered pair of x-intercept, we have 2, 0. To sketch the graph, let us first show the x and y axis, and then let us identify the 4 in the y-axis and the 2 in the x-axis. Then let us draw first the y-intercept, that is the point, and the x-intercept 2, 0, that is the point. And then we simply connect these 2 points, and this is now the line of the function 4 minus 2x. This is our final answer. 1/2 x minus 3. We write the linear form here. F of x equals mx plus b. Let's begin now with finding the slope. The slope is the m. In our linear form, m is the coefficient of x. For this equation, the coefficient of x here is 1/2. That is the m. So we write here 1/2. Now, let's begin with finding the y-intercept. The b here is the y-intercept. The value is negative 3. But we're going to write here as a point. So, we have the x-coordinate to be 0, and the y-coordinate is that negative 3. This is the point y-intercept. What about x-intercept? We will follow this formula, negative b over m. The b is this value negative 3, while the m is the 1/2. So we substitute it here. So we have negative of negative 3 all over 1/2. Let us simplify. Negative and negative becomes positive. So then we copy the 3 times this 1/2, we flip as 2 over 1. Then we multiply 3 by 2, 6, divide by 1 is 6. Then we write this value 6 as a point, and that will be 6 as the x-coordinate, and the y-coordinate is 0. Now we have the intercepts, the y-intercept and x-intercept. Let us plot the 2 points in our xy axis. This is the point 6, 0, and this is the point 0, negative 3. We'll just connect these 2 points by a line. This is now the sketch of the graph of this linear function. Example 4, negative x plus 2y equals 6. Let us isolate here the y. That means negative x we transpose to the right. The negative x becomes positive. So we have now 2y equals x plus 6. Then we divide this equation by the coefficient of y, which is 2. If we do that, this coefficient 2 will come as denominator of the right side. So we have y equals x plus 6 all over 2. We distribute this 2 to the x and to the 6 respectively. So the right side becomes x over 2 plus 6 over 2. We can rewrite our right side. This x over 2 we can write as 1/2 times x, and then the 6 over 2 we write as 3. So we have 1/2 x plus 3. This is our linear function standard form. Remember that the y here is the same with f of x. Now we can collect for the m, or the slope, and the b, which is the y-intercept. Let's begin with the slope. That is the m. This is the coefficient of x, and that is 1/2. This y-intercept is the b. So, we write here 3. Showing this as a point, we write 0, 3. Remember that for y-intercept, the x-coordinate is 0. Now we proceed to x-intercept. Our formula, negative b over m. Let us substitute the values. So we have negative of b, that is 3, all over the m, that is 1/2. We simplify this as negative 3 times 2 over 1. Then finally, the value is negative 6. Showing this as a point, we write negative 6, 0. Remember that for x-intercept, the y value or the y-coordinate must be 0. Now, let us plot the 2 points. This is now the point negative 6, 0, and this is the point 0, 3. We connect these 2 points by a line. And this is now the graph of this function.